Clean architecture can be considered the most evolved form of all those architectures that try to solve maintainability. It takes lessons from existing architectures, adds its own unique contributions, and presents an ultimate picture in the form of a highly maintainable architecture. Before we learn what is clean architecture, we need to learn why we need clean architecture. What problem does it solve? When you start a new project, you have to make decisions, right? Which database do you choose? What cloud service do you go with? Which frameworks or libraries fit the best? What third-party APIs do we need? What hardware and infrastructure will be used? What's the UI going to be? These are all the decisions that you have to make. And no matter how good your decisions are, down the way, things will change and they will keep changing. Maybe a different database or a newly introduced cloud service, probably a better framework, a different infrastructure, maybe another user interface, or a cheaper third-party service. Things will definitely change. And when any of those things change, it often breaks many other areas in the application that depend on that. And that's what makes it worse. The cascading nature of the change. One change in the database that changes the data access layer, then business, then presentation, then UI. Have you ever been in a situation where you were asked to estimate a task and you said 2 days, but then you start working and realized that the actual change is still 2 days, but making that change will affect many other areas of the application. You will have to make fixes everywhere and you will have to test everything again. And suddenly, a simple 2-day task no longer feels simple. This is a problem that almost every developer faces at some point in their career. But if you think carefully, the real problem here is not the change itself, but it's all the other changes you need to make just because one thing changed. The actual change may still take only 2 days, but when everything starts breaking, it makes it a bigger maintainability problem. And that's the problem the clean architecture solves. The problem of change, the problem of maintainability. Now I will show you how clean architecture solves this problem, and I will also demo it in code. Let's see. As we just saw, the problem is not the change itself, but the cascading nature of the change that turns it into a maintainability problem, right? But the good news is we can control this problem because change always cascades in the direction opposite to dependency. A very simple but a very powerful realization. Let me explain. This is A and this is B. A depends on B. This means if B changes, A will be impacted, right? Because A is using B and any change in B can break A. It's obvious. But if A changes, B doesn't care because B does not depend on A. No matter whatever changes we make in A, B will not be affected. It doesn't even use that. It doesn't even have a reference of it. In fact, it might not even know that A exists. So, change cascades in the direction opposite to dependency. And as I said, that's the key realization. Now, what if we take control of those dependencies and design them in a way that favor us? Like this. This is a basic structure of clean architecture. See what we have done here. We have kept the business in the center and all the technical details in the outer layers. And all dependencies are pointing inwards. This means that everything depends on the business, but the business depends on nothing. What does that mean and what makes it so powerful? If you think about it carefully, this means that now there is only one real dependency in the entire architecture, and that's the business layer. This means that change is no longer a problem for all those things that live on the outer layers because no one depends on them. And as we have already seen, change only cascades in the direction opposite to dependency. Since no one depends on those outer elements, nothing will be impacted when they change. So, for example, what if the database changes? Since no one depends on it, nothing will be impacted. We can freely change it at any time. What if we move to a different cloud service or a new framework? Again, there is nothing in the whole system that depends on them, so nothing will be impacted. And the same is true for everything else on the outer layer. This means that just by arranging dependencies in a controlled way, we have solved the problem of change for most of the system. Or in other words, for everything except just one thing, the business logic. Now let's take a closer look at the business logic. If you're not clear about what is business logic, it's the core business. the actual unique solution that a company provides. For example, in a banking application, the business logic is opening an account, checking balance, doing transactions, paying bills, and so on. It doesn't matter whether it stores its data in MySQL or MS SQL or NoSQL. All of these are extra technical details. All of those details might change. But the fact that a banking application allows you to manage your money is something that will hardly ever change. And that's another important realization. Business logic doesn't change very often. By the way, clean architecture typically divides business logic into two layers. The first is critical business rules. They hardly ever change, they come from the real world, and they don't change easily. It's often our understanding of those rules that change rather than the rules themselves. The second is use cases. These are application level requirements that use the core business entities to perform their job. They also change very less frequently. So what does that mean? Theoretically, it means if the business changes, everything else can be impacted because everything depends on it. But practically, the business hardly changes. And even when it does, those changes usually come from clients or product teams, meaning all stakeholders are on the same page. And you usually get enough development time to deal with those changes. So in practice, change doesn't become much of a problem in this area. That's how the core concept of clean architecture solves the problem of change. In addition to these layers, there is one more layer: adapters. Adapters connect the business with the actual technical details. They make those details compatible with the interface defined by the business. Now we will see how we can actually implement clean architecture in code and whether it really solves the problem. We are building a personal assistant application. For any software system, the business is the core. Everything other than the business is just a detail that is architecturally insignificant. So we will begin with the business logic. I have created three use cases: create task, create scheduled item, and send monthly report. These classes contain the actual business logic. In addition, they also need some outgoing adapter interfaces. For example, for create task, we need an interface for persisting the task. Similarly, for create a scheduled item, we need an interface to persist the scheduled item and also an interface for scheduling it on the calendar. And for send monthly report, we need an interface to generate a PDF and another interface to send an email. I have created these interfaces inside the business layer. In addition to those outgoing adapters, we also need some incoming adapters for any code that wants to use the business logic. Note that I haven't implemented those outbound adapters yet. And that's the main idea of clean architecture that I'm going to demo here. Business is the center of every application. Business logic contains the core unique solution that every application provides. Everything else is a detail that doesn't matter. Where you store it, what framework, libraries, or services you use, how you show that on UI, all of these are details that are architecturally insignificant and we can fill later. Whatever you see in this business project, this is the main application. As of now, you can see only 3 use cases. You can keep adding more use cases. Now I will add an API layer so that we can run this code. I will add a reference to the business project and then add the full API layer. The API layer will call the business logic using the incoming adapter interfaces. I will also add dummy implementations for these outgoing adapters so that I can actually run this code and test the business logic. Now I will run the code. First, I call the create task API. It calls the business layer and the business layer calls the persistence adapter. Notice that our in-memory implementation is being used. Next, we run the create scheduled item API. It calls the business layer. The business layer uses its outgoing adapters. First, it calls the in-memory implementation for persistence, and it calls our dummy calendar implementation. And similarly, the send monthly report use case calls the dummy implementations for PDF generation and sending email. And that demonstrates how clean architecture solves the problem of change. For all those technical details, we are calling those adapters without the actual implementation in place. For example, we haven't added a database yet, but our code is still fully functional. So how can we depend on something that doesn't even exist? And that's exactly the point. We have made all those details architecturally insignificant. Now, whenever we need to add a database, all we have to do is add a new project, add a reference to the business project, add the required NuGet packages and dependencies, and provide implementations for the interfaces defined by the business. Then we do the necessary setup, and finally configure those dependencies in DI. And now I will run the code again. And this time, as you can see, the actual database implementation is being used. The data is now being persisted. But we didn't make a single change to the business logic or any other area of the application. As you can see, clean architecture naturally enables a plugin based architecture. And in the same way, we can implement the other adapters. All we did here was add a data access layer and configure it from the main component. We can switch to a different implementation at any time when needed. And not just the database, we can replace any incoming or outgoing adapter whenever we need to. So, for example, if you want to move to a different calendar service, we can simply follow the same steps. Note one important implementation challenge. At runtime, the API layer calls the business layer. And at compile time, the API layer keeps the reference to the business project and depends on it. This means that for all incoming traffic, the direction of flow at runtime and the direction of dependency at compile time are the same. But if you look at the outgoing adapters, you will notice something different. The business calls them at runtime, but the business doesn't depend on them at compile time. Instead, those adapters depend on the business. Naturally, dependencies tend to follow the direction of flow. But in this case, we need them to flow in opposite directions. And we achieve this through Dependency Inversion Principle. How do we achieve that? We define the interfaces in the business layer, just as we have done here. Then in adapter project, we add a reference to the business project. Next, we implement those interfaces there. And finally, in the main component, we add references to both the business and adapter projects and map the implementation to the interface using DI. Then at runtime, the implementation is injected without the business knowing anything about it. This means that at compile time, the calendar adapter depends on the business layer. But at runtime, the business layer calls the calendar adapter. And that's how the business layer can use those implementations without even knowing about them. Now suppose we need to add another user interface. Let's say we want to introduce a command line interface. We simply add a new layer for the command line interface, and it can be added without changing anything else. Now we can use the same business logic from the command line interface. And similarly, we can add more incoming layers such as GraphQL or SignalR. And in the same way, we can keep adding or replacing or changing all the adapters. Let me demo one more thing. Suppose we are using a particular library for serialization and deserialization. We have added the library following the clean architecture way. If I run the code and call the serialize and deserialize methods, the given implementation will be used. I'm using these methods all over the project. Now suppose I want to move to a different library. I will add the reference of the new library, implement the same interfaces, update it in the DI, and now when I run the code, the new implementation will be used. We just moved to a different library without making a change anywhere else. That's what makes it a highly maintainable architecture. That's how clean architecture solves the problem of change. This is a basic explanation of clean architecture. There are several advanced concepts that I haven't covered in this video. For example, it discusses how to separate different domains using partial boundaries and also provides guidance on microservices architecture. Let me know if you would like me to cover those details. With clean architecture, adding new capabilities in the system becomes remarkably easy. Next, I will show you how we can add an AI agent in our application. I'll show you how clean architecture makes it really simple to add an AI agent in the system.